Hello everyone, my name is Michael Helmer and I speak to you today from our Emerson tank gauging factory in Gothenburg, Sweden. Today we will share with you some solutions on what can be done to increase tank shell capacity in your storage tanks. First, a little background. Currently, global storage capacity has or is soon reaching its maximum limits. Increasing tank shell capacity and being able to do it now is important. The ongoing COVID-19 pandemic, along with the recent oil price developments, has caused a surplus in supply of liquids and products, which in turn has rapidly filled up available storage space across the world. Finding solutions to address this is very important, since tank terminals that are storing energy, chemicals, and other products are deemed critical infrastructure for global logistics supply chains, and hence are vital for our way out of the current crisis. A good utilization and a working and safe operation is therefore of essence. Emerson is also deemed an essential and critical infrastructure provider in support of, for example, the terminals industry. We have our factories up and running all around the world, and we're here to support and guide you on product and solution selection to address your site operation challenges. We are ready to fulfill your orders, build and ship them with a short lead time. You could argue that one way to address the lack of storage space would be to build more storage tanks, but it is more costly, it requires more land space, and it normally takes quite some time. So therefore, it is of interest to maximize the amount of product in each tank, but it's also critical to maintain high levels of safety in this operation. So what if you could quickly maximize the tank shell capacity you have today? We will now explain and help you do that through a short presentation. And to do that today is our North America team. Lance, handing over to you, please.
Thank you, Michael. So today's topic is how to increase tank capacity while removing cost. It sounds counterintuitive, I know, but there are digital solutions to tank issues you can deploy today. So let's get started. To keep up with the changing customer and market demands, a terminal must be equipped to efficiently use tank capacity, maximize transfer rates, and save costs, all without jeopardizing safety. But there may be roadblocks ahead that prevent you from achieving this. Some tasks associated with managing the tank inventory and the movements are still performed manually. As we all know, labor is the most significant cost for any site. One of those manual tasks is the actual tank gauging, along with the overall inventory management calculations. Another big challenge is the potential risk for overfill by not having an automated system and properly managing the levels inside the tanks. If the tank does not have the proper number of openings, there could be added costs for upgrading the tank gauging system and adding a separate overfill prevention device. These are all hurdles to remaining safe and being competitive. So how can we get higher capacities and transfer rates without increasing risk or costs? Depending on the location, terminals may or may not have automatic tank gauges, or they may have an older type of tank gauge that require them to add a greater safety margin in the tank, and this sacrifices tank utilization and ultimately revenue. If we look at the diagram to the right, you'll see the maximum working level line. This is the maximum operating level in the tank. The line above it is the high level alarm point, a level significantly below the critical high level to enable termination of a receipt before there is an overfill. If you have manual operations, there's somebody manning the valves and another doing the hand gauge. The risk of overfilling is also impacted by the transfer rates into the tank. If the operations are as previously described, then the inbound rates are adjusted to reduce this risk. This essentially means slowing down the inbound flow to avoid quickly reaching overfill levels and having some time to shut down the operations. In terms of cost, with manual operations, you typically need 2 people. This associated cost to obtain an accurate physical gauge and to reconcile that inventory is significant. This is 2 people operating 1 tank. Imagine a facility with over 100 and the impact on the complexity of just the labor component alone. Sometimes there are separate gauging and overfill prevention devices. When that happens, the installation cost could be higher since it's the installation cost for multiple systems, not just one. And this requires more time, more equipment, and more construction and proof testing costs. So the question is, does it really matter whether greater use of the tank shell capacity is in play or not? Well, it turns out that not using the full tank capacity obviously leads to sacrificing revenues due to suboptimal tank levels. In the picture on the left, we delve a little deeper into the maximum working level versus high level versus critical high level. T1 and T2 in the diagram refer to the response time between shown levels. Shutdown occurs at the high level before it goes to the more dangerous critical high level and overfills the tank. The response times are indicated by the delta between these levels of concern and are developed in compliance with API 2350. API 2350 is a recommended practice for overfill prevention in storage tanks. These levels of concern and response times are based on the operating philosophies and management systems of the terminal company. With a manual operation or an outdated tank gauging system, the response times will need to be longer, and in turn, the total utilization of the tank is decreased, therefore sacrificing tank capacity and revenue. On the right is an example of what it means economically in terms of cost improvement for a hypothetical tank farm with 100 tanks. In the upper quadrant, you'll see that the assumption is 12 manual gauges per year for monthly verification. This does not take into account the opening and closing gauges that take place with every movement in and out of the tank. Assuming a labor rate of $59 an hour, the cost is $708 per tank per year. For 100 tanks, this would be around $70,000. In addition, most mechanical overfill devices require a monthly proof test or verification to confirm they are operational. If we use the same labor rate as above, the annual cost is around $23,000. If we combine both these requirements, it is around $100,000 per year, or about $1,000 per tank, that the terminal operator could be saving by having an automated system. There are some costly consequences to avoid. Unloading a barge into a tank may require one person for the entire operation and two more during topping off the tank. Not having extra capacity could cause the terminal customer to incur demurrage fees and possible product value loss, subjecting the terminal to claims to recover said expenses. In practice, many existing tanks lack available nozzles to add an overfill gauge. Adding nozzles or still pipes is cost prohibitive. Then there's the latent risk of overfill. And while we hope it never happens, it does happen once every 3,300 fillings across the world. This data comes from the insurance brokers Marsh & McLennan. They study these risks, and the rate of realization of these risks is very costly in terms of dollars, and if not more importantly, industry and social reputation. And of course, nobody wants to be in the news. Wouldn't it be better if you could implement a high-accuracy, dual-purpose level and overfill prevention device on each of your tanks in a cost-effective way? This would allow you to increase capacity and transfers while reducing overfill risk and improving level measurement accuracy. Imagine if a terminal can utilize more of its tank capacity, even if it was just 5%. Over 100 tanks, that is a significant capacity creation without having to build a single tank. It also allows the terminal customer the opportunity to place more of its inventory in the tanks, which provides more throughput and more fees for the terminal operator. These systems operate automatically and provide measurements that are more accurate and more reliable, which drastically reduces the labor component and overall OPEX, not to mention operating more safely. Finally, the reduced CAPEX that is achieved by using a 2-in-1 level and overfill gauge that only requires a single tank opening for fast installation, commissioning, and reduced project and operational costs. It should be obvious that an automated overfill prevention system, along with a modern automatic tank gauging system, can increase operational efficiencies and allow tank farms to gain a commercial advantage. So let's dig a little deeper into Emerson's Overfill Solution, the 5900S 2-in-1. The Emerson Rosemount 5900S takes overfill safety to a higher level with an innovative 2-in-1 feature which includes 2 radar gauges in one housing, one for independent level and one for overfill measurement. It is SIL 2 or SIL 3 certified according to IEC 61508 and enables API 2350 compliant solutions. The The Rosemount 5900S radar level gauge delivers 0.5 millimeter accuracy, reducing level measurement uncertainty to a minimum. It enhances your storage operations by providing certified custody transfer accuracy, better inventory management, and reliable loss control data. For complete inventory system, the 5900 is normally combined with a high-precision multi-spot temperature sensor for highest accuracy of the API net volume calculations. Some other features and benefits include being able to use wired or wireless communication. It can even talk over your existing legacy system using emulation. We have seen up to a 70% reduction in wiring costs by implementing wireless, and then you have an open infrastructure to add other devices. Another key benefit is it will connect to a safety instrumented system for overfill shutdown independently of the tank farm inventory monitoring system. It also facilitates a reduction in installation costs by adding overfill prevention to an existing tank without the need for an extra tank opening. The 5900 radar gauge has a much longer proof testing interval than traditional mechanical type devices, which means that the cost and the frequency of proof testing is reduced significantly. Finally, it's the most cost-effective way to comply with API 2350 as well as 61511. While all this is great, let's look at some examples from customers. Here's 3 customer proofs that show the delivered value of the 5900 system. The first being New York terminals, where they achieved increased profitability and safer operations. They wanted to minimize manual work to save on operating costs. It was also important for them to use their tank capacity more efficiently and maximize their transfer rates without jeopardizing safety. They implemented the 5900S 2-in-1 system, and the results were improved tank utilization, enhanced operational safety, and minimized manual work. Their reported cost savings were 30% per year. The rate of throughput also increased by 15% as a result of not having to significantly slow down inbound transfer rates at higher levels in the tanks. 24/7 online availability of accurate and reliable tank data was a huge benefit as well for them and their customers. The second example is a chemical terminal in Texas City that looked to improve revenues and safety. They installed the 5900S 2-in-1 system as they had limited openings in the tanks. They reported the installation cost was much lower due to the 2-in-1 concept. They realized immediate improvement in their inventory reconciliation and utilization of their tanks along with increased safety. Their maintenance cost was drastically reduced by using non-mechanical level gauges and overfill devices, and the reduction in proof test intervals. Lastly, we look at the terminal in Gothenburg, Sweden that was looking to increase efficiency and reduce risk. The legacy tank gauging system was outdated and needed to be replaced due to product obsolescence and decreasing availability of spare parts. So again, the 5900S 2-in-1 system was installed. The results were online and highly accurate tank gauging data available through the DCS, compliance with new company safety requirements, as well as cost-efficient installation due to minimal tank and infrastructure cost. This concludes my part of the presentation from Texas, and I will hand it back over to Michael in Sweden.
Thanks for that, Lance. I hope that was useful for everyone. Today we talked about the challenges with efficient storage and transfer and capacity. We've also explored the impacts from both a financial and safety perspective by doing nothing different than done today. Fortunately, we as Emerson are able to deliver and have solutions for these challenges already today. And in many cases, we have the stock available at our local facilities and can deliver to you with very short or even shorter lead times. As we are also deemed a critical infrastructure provider, we are here, open, running our business to support you in these challenging times. You can reach us through our webpage, emerson.com, Rosemount Tank Gauging, or at any of the local numbers, emails, and addresses that you can see on the right-hand side. Thanks a lot for listening. Bye.